Good morning, everyone. My name is Justin Sears. I'm a product marketing manager at Hortonworks, and it's my pleasure to host our 7-webinar series entitled Discover HDP 2.1, covering all the new capabilities for Enterprise Hadoop delivered in Hortonworks Data Platform version 2.1. Today's new features for security in Apache Knox is the first webinar in the series. I'll be your host today, and I'm joined by two Hadoop security experts. Vinay Shukla is a director of product management at Hortonworks. He is responsible for the security roadmap in Hortonworks Data Platform. Kevin Minder is a Hortonworks engineer and committer for the Apache Knox Gateway project. Here's today's agenda. We'll begin with Hadoop REST API Security with Apache Knox Gateway. Then we'll cover HDFS security with access control lists, or ACLs. And we'll finish with SQL security and next generation Hive Authorization. We've got 30 minutes, so we're going to move quickly. All attendee phone lines have been muted. If you have questions during the presentation, please send them to Kevin Minder in WebEx chat. He'll be gathering those and we'll answer them towards the end of the call. If we don't have time to answer all of the questions, we will include a full Q&A in an upcoming blog post about this call. Let me set the stage for Vinay and Kevin. This is a diagram of modern data architecture with Enterprise Hadoop to store and process data from a wide variety of sources. Data comes in structured columnar formats and also newer, less structured formats like those found in human-generated content like Word documents or videos, in weblogs and clickstreams, social content like tweets, and in machine, sensor, and geolocation data. Those are the data sources you see down at the bottom. Apache Hadoop works well in combination with familiar data repositories like RDBMS, EDW, and MPP in the middle layer here to store and process a full spectrum of data. That data is then available to a variety of data access applications at the top of the stack and BI tools to complete many different data workloads like batch processing, interactive query, stream analysis, NoSQL, search, and others. Through our experience with more than 100 enterprise customers running HDP, we know that enterprises need 5 core capabilities for in Enterprise Hadoop. Aside from data management and data access, which we see in the middle of the diagram, they need data governance and integration, they need tools for cluster operations, and of course they need to secure their Hadoop cluster. We'll cover security in today's webinar and the other 4 components of Enterprise Hadoop in additional webinars over the next 7 weeks. So now I'll turn it over to Vinay Shukla. He and Kevin will discuss HDP 2.1's security features. Also, if there's time, Vinay will also touch on the future roadmap for security. So please remember to send any questions to Kevin Minder during the chat. We'll get to those at the end of the call. And let me turn it over to Vinay. Vinay, let me pass.
Thanks, Jeff.
Let me pass control over to you. Okay, it's all yours, Vinay.
Okay. Can you guys see my screen?
I sure do.
Okay. Thanks, Justin, and thank you for joining the call. So we are very excited to talk about security in HDP 2.1, and let's get into it. So security in Hadoop, as in any system, is there are very common patterns, and on this slide I'll start with those common patterns. So security has 4 pillars: authentication, authorization, audit, or some people call it accounting, and encryption or data protection. And another key principle of security is defense in depth, and that's applied by rings of defenses, and it's the same in Hadoop as well. So at the outermost layer is the perimeter level security, and there are different flavors of it. So you can think of it as firewalls, or you can think of it as gateways, and Apache Knox fits in that layer. The next layer of security with Hadoop is authentication, which is applied using Kerberos. the level beyond that is authorization. And as you can see on the left-hand side below authorization, there are different capabilities spread across different areas of Hadoop. So MapReduce has access control list. HDFS had permissions before HDP 2.1, and now it has access control list that will go into detail. And starting 2.1, there is Hive Authorization, next generation, and so on. And then all of this is still predicated on the OS level if the OS has been configured securely, or if you're deploying your Hadoop deployment in a cloud-like environment, you can think of the cloud security is also important. And that's the baby Hadoop. And all of that encryption, both at rest as well as data in motion, is still important, and that comprises the holistic picture of security. So when you're looking at security, you have to think about across all these areas in any system, and Hadoop in that sense is no different. So now let's go into what is Apache Knox. So Apache Knox is GA for the first time with HDP 2.1, and we've been working for it for some time. But before we go into Apache Knox detail, you have to ask, why do we need to come up with Apache Knox? So a basic requirement many enterprises have is they want to extend the reach of their Hadoop cluster, either to like partners or vendors outside of their environment, or just to more departments. And if you want to extend the reach of your Hadoop cluster, you still want to have your security, but you don't want people to have to face the cost of security. So with the current model, where a lot of people access a Hadoop cluster in a secure fashion via a Kerberos environment, they use SSH client to go to a node where they have Kerberos client installed, and then they talk to Hadoop cluster. And this model works, it's secure, but the problem is it's not a very extensible model. It works for a small number of users. So to solve this problem and extend the reach of sort of like extend your Hadoop cluster to more users, and also simplify access to Hadoop, we provided Apache Knox, and as you'll see in the next couple of slides, the architecture of Apache Knox. So the benefit of Apache Knox is that it simplifies access. So if you're talking about REST APIs of Hadoop component, before Apache Knox, you can have like X number of different Hadoop components, each having its own REST APIs. You don't want your users to have to remember the host port for each REST API and all. So with Apache Knox, there is just one access point to go through. Apache Knox also combines multiple Hadoop cluster, it can. If you have multiple Hadoop cluster, you can put them through Apache Knox. So that sort of like simplifies the access. And at that central choke point of Apache Knox, you can put security, so you can centrally put authentication, authorization, audit for all your REST APIs going through Knox. And it also does identity management integration with SSO based on SiteMinder today and more in future. And we also do LDAP and Active Directory integration. So essentially, the key benefit of Knox is that it eliminates the need for client to know the internal topology of a Hadoop cluster. So this diagram will go more deeply into it. So you can see in this diagram a cluster of Hadoop gateways, or Hadoop cluster is being fronted by Apache Knox gateways. And Apache Knox in this diagram is put into DMZ, but nothing in the Knox architecture dictates that it has to be the DMZ. It can be behind the firewall. And I know of some customers who want to put Apache Knox within the firewall, same place, co-located with the Hadoop cluster. So both deployment models are possible, but I think for most security, this deployment model is probably the most secure, but you have to weigh it against the usability. So the way Apache Knox Gateway works is any REST client will come through a load balancer, and Apache Knox, there can be one or more instances of Apache Knox, and the load balancer is configured to do round robin or other load balancing algorithm through Apache Knox. And it's Apache Knox Gateway will then route the call to appropriate Hadoop cluster. If you have only one Hadoop cluster, then that's all you configure. But if you have multiple Hadoop cluster, Apache Knox will determine where the call needs to go. based on the routing rules it's been configured and the URLs that you're trying to access. And so that's the model. Your existing Hadoop clients, the one you saw in the previous slide where I showed the SSH example, they are typically coming through the RPC calls, and that's the edge node in this diagram. So in summary, Apache Knox simplifies the client interaction with the Hadoop's REST web APIs. It abstracts away the complexity of Kerberos, and it integrates with LDAP, SiteMinder, and other identity management protocols in future. And it provides authentication, authorization, audit to all the REST APIs going through it. And it becomes the one single point of access and for your Hadoop's REST API. So let's go into other in security. So the next one is HDFS access control list. So we all know that the permission model for HDFS before HDP 2.1 is based on POSIX. Somebody's typing, can you mute yourself? So we all know that the model for HDFS permissions is based on POSIX before that. So what it implies is that each the permission on a file or a directory is represented as an octet. So it's just like in Unix or Linux. So read, write, execute for self or user or group or others. So you can have just one user specified in that or one group, and everybody else falls in the others. So the model works for a large variety of use cases. For example, if we go to this slide, let's say our requirement was that a single user, we call Maya in this example, will be able to manage the data that exists in sales data folder or directory. And that model can be implemented that she will have access to read, write sales data, and the department sales will have access to read the data but not write the data. And with current HDFS file permission model, this model can be represented as as shown on the screen. But let's say the requirement change in future, and we now want, besides Maya, more users to be able to make modifications. And we also want the executives of the company to be able to read the data besides the current group of sales. And executives are not in the sales group. So before HDFS ACL, if we had to get this use case working, we had to make workaround. For example, one workaround was put executives and salespeople in the same hybrid group. But then this is not a clean, as in any workaround, this is not a clean model. And so to prevent such workarounds, we have the new HDFS ACL. So let's look at that in more detail. So with HDFS access control list, you get new tools such as set file ACL, get file ACL, and you set the file. So there are different commands for that. It's not just DFS shamad, but you have a new tool for setting the ACL. So now you can see, you can set the access control list on your sales data directory, and you can make executives also able to read the data besides the sales group. So that way you now have more flexibility with the HDFS access control list. And how do you know if a directory has an ACL set? It will have a plus sign if you do read it through a DFS list. You'll see that it has a plus sign next to it, and that's the indication that there is ACL set on that directory. Now let's talk about the default ACLs. So you can set the default ACL as well. So the default access applies not retroactively, but from that point onwards. So if you set the default ACL on a directory, then all the files or children of that directory will have this default access. So let's dive into the next section, which is the SQL style security in Hive. So on this, I'll go into more detail. So before HDP 2.1, there are two permission models in Hive. One is storage-based authorization provider, and the second is default Hive authorization provider. So the storage-based authorization provider leverages HDFS permissions to make authorization decisions, where HDFS directory permission is same as the table permission. It's a coarse-grained. It does not provide column level or row level security, but the model is secure and it serves a large variety of use cases, as we will see in the next few slides. So if a lot of people are using it and it's been there for a while. The second authorization provider in Hive is default Hive authorization provider. And if you were to just Google Hive authorization, this is the Hive authorization provider you link to, and you'll think that this looks good and you may want to use it. But please remember that this is a broken Hive authorization provider, and we don't recommend using it. And the reason why it's broken is it locks a door or a house, but it does not secure the key. The key is just under the mat. And how it does that is because there is no permission check on policy grants, so anyone can grant policy to themselves. So please don't use that. And why is Hive authorization such a complex thing? Because we have to remember there are many paths into Hive. There is Hive CLI, there is Beeline, there is Oozie, Hue, Pig, Catalog, etc. And there are different categories of users who are trying to access Hive information. There is admin type users that use CLI, Pig, or Catalog, and then there are often business users that either come through business applications or other mid-tier applications, and they typically come through JDBC or ODBC or in rare cases through Beeline. And Beeline, as you'll see under the covers, uses the JDBC interface. So with Hive authorization that we'll talk about the next generation, as in any security system, authorization is only meaningful after authentication is done. So that's a prerequisite. It also ensures that the end user or does not have direct access to HDFS. The cluster is Kerberized and restricts access. Hive Metastore is protected. And views are what is used to provide row and column level access. So let's look into different paths into Hive authorization, or actually Hive. So the way to enable Hive authorization is with Ambari, you can configure Hive server to have Hive authorization enabled, and then calls coming through JDBC or ODBC or through Beeline CLI, they go to Hive server 2, and Hive authorization is embedded in it. And Hive authorization consults the policy for the table or the view that's being accessed by the user, and the policy is stored in the Metastore. And if the user has access to it, it lets the call through, and then Hive Server 2 then reads the data from HDFS and presents the data back to the user based on whatever was in the query. So that's how Hive authorization is plugged in. You'll see on this diagram the darker shades of green and those arrows, that's where the fine-grained Hive authorization is available. The lighter shades of gray or green have coarse-grained storage-based authorization available. So both models have security. And the Hue, as I mentioned on the previous slide, Hue, Oozie, Hive CLI, Pig, and HCAT, those are the calls that are typically done by a privileged users or a limited set of users. So for them, storage-based authorization is sufficient. So that's the Hive authorization architecture. Let's go into more detail. So I mentioned Hive authorization is a SQL-based authorization. What it means is that the interface to an end user is very much like how you configure authorization rules in SQL. So you do grant or revoke on a table or a view to a role or a user. And that model is familiar to anyone who has done any security in database. And so that's a very familiar model. The policy, as I showed in the previous slide, for Hive authorization is stored in Hive Metastore. And the benefit of that storing the policy in Hive Metastore is that the table and the view lifecycle is in automatic sync with the policy stored in Hive Metastore. With some other models, the policy may be out of sync or there are dangling references, not with Hive authorization. and the grant revoke does the integrity check, prevents invalid policies. So you cannot do a grant or a revoke to a table or a view that does not exist. And similarly, to look at the policy on a given user or table or view, there are show grant statement available just like in database, and it supports delegated administration. So let's look into more detail. So this caveat about, so how do you secure MapReduce, PIG, Hive CLI? So as I mentioned on the previous few slides, these are ETL type jobs run by privileged users, and you can protect them with storage-based authorization users. So in summary, Hive Authorization is a superior approach for Hive because it's familiar and DBA friendly. It's integrated with policy definition and thus error-free. And there is minimal overhead, operational overhead. So what's the example? So I've made this use case, and my use case is that we want to share our product management roadmap securely. Our product management roadmap is stored in some database and table. And we have two roles, product management role and engineering role. And because the roadmap is product management roadmap, we want to say that product management should be able to read and write the roadmap. And there are two members of product management role, myself and Tim Hall. And then in engineering role, we have put two members, Kevin Minder and Larry McKay. They should be able to read the roadmap but not modify the roadmap. So if this was the use case, and before I go to the next slide, the key thing is the admin role at the top on the slide here, which is specified in Hive site, and the admin role controls the role membership. So on this slide, imagine the admin person doing this. So he creates the role product management, the product management role. He creates the role engineering and puts appropriate users in the appropriate role. So the admin user will put in the product management role user Tim Hall and user Vinay Shukla. And note in the command number, the example 3, Tim Hall is given with admin option. That means Tim can further manage. He becomes the delegated administrator of the role PM. So Tim can further control the role memberships or other operations on that role, whereas Vinay Shukla cannot do that. So that's step 1. Step 2 is the admin creates the tables or views where we are where we'll store our super secret roadmap. And then we'll do a grant all, which implies read and write and all other operations on that table to role PM, and we'll grant select on that table to role engineering. And then this is the way we'll simply achieve the use case. So we've covered a lot about security, and I was mocking when I said our roadmap is super secure, because it's not. If you go to hortonworks.com lab security, you'll see that the product roadmap is what we have published last year, and we just keep on delivering that, and we now have successfully put the delivered stamp on the phase 2 of it. This labs page does not mean that the stuff is not ready. It just gives an insight to you that what we have announced, we announce things ahead of time, that here is what we are thinking about working on, and here is what is coming, so our users are more aware of it. And just like our rest of the company, it's all about openness and transparency. With that, I thank you for your time, and I'll hand it back to Justin for Q&A. Or if there are questions on the chat, we can go in there.
Thank you so much, Vinay. Kevin, I know that a lot of questions have been coming in. Let me take Kevin off mute. And Kevin, if you could read out some of the questions and the answers that you've given back, that would be great. Go ahead, Kevin.
So one of the frequent questions is the session being recorded? Will we have access to it? And the slide.
And the answer to that is yes, that will be in an upcoming blog post on hortonworks.com. We are recording this session, and any questions that we don't get an answer to on this call, they'll be included in the upcoming blog post.
Okay, great. Second question was, is the Knox Gateway a single point of failure? Answer, that's no. It can sit behind a traditional web load balancer like Big IP or Apache mod proxy. So that's how Knox scales and handles HA. Let's see. Is Knox limited to a certain set of web APIs that it wraps, or is it extensible to handle other things? The answer to that is yes. Knox has a plugin framework where it can be extended by building jars that reference the framework and dropping them into an install. So we'd be happy to hear in the Apache dev community any interest anybody had there. The next question is, does the Hive authorization stuff apply with PEZ? And I'll have to get a follow-up to this from the Hive guys, but I believe that yes, the Hive authorization applies equally well to whether you use Hive or not, or TEZ or not. There was a question about the management of Hive authorizations, or no, this is HDFS, ACLs with Active Directory, and that requires a bit of clarification, I think. So the metadata associated with the HDFS ACLs is stored in the name node metadata namespace. So while the users and groups may come from Active Directory, the actual ACLs are not managed there. There was a question about whether Hive authorization, the new Hive authorization model, is pluggable, similar to PAN. Again, I'll follow up with the Hive guys for a more detailed answer when we post the question and answer. But the initial answer is no, that there's a plugin model that was enhanced in Hive into which the Hive authorization was plugged in. But the model that's plugged in for the Hive authorization you can see is not itself extensible. Going down, there's a new question. Where does Apache Sentry fit in? Can
I take that one?
Yes, you may. And then we need to get back to Justin, so we're about out of time.
Okay. So let's make that the last question. So Apache Sentry is a good authorization solution. Unfortunately, it does not provide the SQL standard-based solution. So as you saw the previous slide, the authorization model was that you can create a revoke or grant just like SQL. With Sentry, there are a few issues that the authorization policy is not stored in the same place where the table is. So you drop a table and you'll have to keep the policy in sync. And we looked at Sentry and we wanted to use it, but then it didn't solve the use cases we are after. So in a way, Sentry and Hive authorization next generation try to solve the same problem, but they are very common in the architecture. They're slightly different in where they store the policy and the lifecycle around it. So with that, I think we reached 9:30. I'll hand it back to you, Justin.
Wonderful. Well, thank you, Vinay and Kevin, for taking the time to share your expertise around securing Hadoop clusters so that Hadoop data can be accessed by a broader set of stakeholders within the enterprise in a way that aligns with company data access policies. And I want to thank all of you for taking time today to learn about how security is integrated with HDP 2.1. A recording of this presentation will be included in an upcoming blog post as well as a Q&A, so if we didn't get to all of your questions, those will be included in that blog post. And then if you haven't signed up for the other 6 Discover HDP 2.1 webinars, you can do that from hortonworks.com/webinars, which is you can see on the slide right now. Next Thursday, May 15th at 10 a.m. Pacific Time, we'll hold the second webinar in the series, Interactive SQL Query in Hadoop with Apache Hive. I hope you can join us for that next week. This ends today's webinar. Thank you very much for attending.